look at an application where we're going to need to use the distance formula and the midpoint formula. As a reminder, the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And the midpoint formula is going to give us an ordered pair where the x-coordinate is the average of the two x values and the y-coordinate is the average of the two y values. So let's read this problem. The medians of a triangle are the line segments from each vertex to the midpoint of the opposite side. So a vertex of a triangle is one of the corners here, and the median is going to be the line segment that runs from one of the vertices to the midpoint of the opposite side. So this is one of the median values. Another median line segment runs from a vertex to the midpoint of the opposite side, and another median is one that runs from the vertex to the midpoint of the opposite side. So these are our three medians. And we're being asked to find the lengths of all three of these medians with the triangle where the vertices are located at 0, 0, 6, 0, and 4, 4. So let's actually come up with a sketch of a triangle that has these vertices to help us to understand the question that's being asked and our answers when we find them. So our first ordered pair is at 0, 0. And then we have another ordered pair at 6, 0. And then our third ordered pair is at 4, 4. And we'll call this our point C. So we have a triangle that looks like this, and we want to find the segments or the lengths of those median sides. So let's start off with this first one here where we're going from point A to the midpoint of the opposite side. Well, the first thing that we need to do is actually figure out what is this midpoint value. And to stay organized, let's identify the midpoint between C and B to have this notation. That midpoint value is going to be the x-coordinate of C plus the x-coordinate of B, and then we're going to divide that by 2, getting the average of the two x values, the y-coordinate of C plus the y-coordinate of B, and then averaging those. So our midpoint turns out to be 10 over 2, 4 over 2, which is 5, 2 as an ordered pair. And based on our graph, that looks about right, that this ordered pair would be situated at around 5, 2. Now we want to find the length of that line segment, or the distance between point A and our midpoint. So let's go ahead and figure out this distance quantity. So that's going to be x2, as we see from our distance formula here, and we can really just say, let's let this be x2, or the second point. So x2 is going to be 5 minus x1 will be 0, plus y2, which is 2, and then we're going to subtract y1, which is 0, and then quantity square that. So we'll have the distance is going to be equal to 25 plus 4, or radical 29. So the length of this median line segment is going to be square roots 29. But I'm going to move that down here because we're going to need to do this 2 more times. So the next thing that let's do is to figure out the midpoint between the points A and point B. Well, we can actually figure out the midpoint here pretty easily because A and B are on the x-axis, and if I go from 0 to 6, the midpoint is going to be at the ordered pair 3, 0. So let's skip the midpoint formula here because the ordered pairs are simple enough for me to determine that the point halfway in between has to be 3, 0, in between 6, 0 and 0, 0. And then we're going to find the median, or the length of the line segment that connects these 2 points. Let's do this one in blue. That length is going to be determined by the distance formula. So we'll say it's the distance between point C, which is 4, 4, and this midpoint on the opposite side, 3, 0. So let's say C is the second point, and we'll go x2 minus x1 quantity squared plus y2 minus y1 quantity squared, right? We're going for the distance between this point and this point. So we get here 4 minus 3 is 1, quantity squared is still 1, and then add that to 4 minus 0 is 4 squared is 16, and then the length of that median is going to be rad 17. So let's tuck that value up here so that we have space to find the length of the third median. So the third median is going to be measured from point B to the midpoint of the opposite side. And this time we are going to need to calculate this midpoint because it's not quite as intuitive as it was a moment ago. So what we're looking at now is going to be the midpoint between A and C. So what is the midpoint here, halfway in between A and C on this opposite side? So we're looking for the midpoint between point A and point C. That's going to be taking the average of the x-coordinates, so we'll say 0 plus 4, the x-coordinates added together and divided by 2, and then the average of the y-coordinates, the same, 0 plus 4 divided by 2. Well, that's going to be 4 halves, which is, of course, 2, 2. So this midpoint seems to be appropriately located at the ordered pair 2, 2. Now, after we find the midpoint, this is when we can look at the distance or the length of that median. So we want now the distance between those two ordered pairs, 6, 0 and 2, 2. So now we're looking at this distance being the square root of, let's let 6, 0 be our second ordered pair, 2, 2 be the first. So we'll say x2 minus x1, which is 6 minus 2 quantity squared, plus y2 minus y1, so that's going to be 0 minus 2 quantity squared. So this will be 4 squared plus negative 2 squared, which is 16 plus 4. So this last distance, I'll wrap it around here, is square root 20. We'll say that that 20 is the same thing as 4 times 5, so that's the square root of 4 times the square root of 5, which is 2 rad 5s as this final distance here. And let's label that up on our graph that this distance, or the length of this median, is tucking it into here, 2 rad 5s. So we've got 3 median distances. One of them is 2 rad 5, one of them was rad 17, and one of them was rad 29.